So now it's time to put the half-angle trig identities to work. We're going to use these half-angle identities to solve this problem. If we know that there's an angle phi on a standard coordinate plane such that the secant of phi is negative square root of 53 over 2, and the cotangent of phi is less than 0, I want to know what's the sine of phi over 2, what's the cosine of phi over 2, and so on. And it's pretty obvious we need the half-angle identities to help us through this one. And I have them written right here, just in case you haven't memorized them yet, although you should. And if you can't memorize the half-angle identities, if you're having trouble with that, you can rederive them from the power-reducing identities, which you've memorized, of course. And if you haven't memorized these, well, you go back to the double-angle identities, and you use the double-angle identities to get the power-reducing identities. And if you haven't memorized those, you get them from the summation identities. And if you haven't memorized that, you are in trouble, dear student, because you're going to be taking a test on this stuff, so memorize some identities. Now, let's do sine phi over 2, and I want to use the same color here. Okay, so this is blue. I'm just going to use the same color, make this a little easier. We have this. I know that the sine of phi over 2 equals plus or minus the square root of 1 minus cosine phi over 2. Okay, that's my trig identity for sine. And how do I apply that using this information? Well, you might remember we spend a lot of time drawing triangles on a standard coordinate plane, so I'm going to do that. And I will give you some good news. This is easier than when we're dealing with the summation angle triangles, because there's only one triangle here. It's just the angle phi. So let's take a look at what we're given. Cotangent is less than 0. Where's that true? If you know your coordinate plane, you know that cotangent is less than 0 in quadrant 2, and cotangent is less than 0 in quadrant 4. So I'm not sure where I am. Well, let's look at this. Secant is negative. Okay, secant is less than 0 also. Well, if secant is less than 0, that means cosine, which is the reciprocal of secant, is also less than 0. Now, where's cosine less than 0? That's in quadrant 2, and it's in quadrant 3. But if you go to quadrant 4, cosine is actually greater than 0 over here, right? Cosine's the x-coordinates. So this is no good. And we're going to have to use quadrant 2. So this is a big win. Now we know where we should draw our triangle. Okay, so let's go ahead and I'm just going to clear this stuff out of here. We're going to draw our triangle now in quadrant 2. And remember, I don't care about the accuracy of the shape of the triangle. It's not important. What I care about is just getting a general diagram on here so I can put some values on the legs of this triangle. Now, back to secant. If secant of phi equals negative root 53 over 2, I know not everyone's memorized what secant looks like on a triangle, but you should know from the reciprocal identity that this means cosine is going to be negative 2 over square root of 53, right? And according to SOHCAHTOA, which you have memorized, that means, since we're looking at cosine, adjacent over hypotenuse is going to be 2 over square root of 53, or negative 2. So here's my square root of 53. Here's my 2. Which one of those needs to be negative? If you think about it, you remember you cannot have negatives on the hypotenuse. So it must be this side right here, which also makes sense because we're going in the left direction. Okay, when you're going to the left, that means x is negative. All right, super. So now, what is the y-coordinate? Or what's the length of this other side of the triangle right here? Okay, I want to know that guy. And if we do a little Pythagorean theorem, I'm going to say negative 2 squared plus, well, I'll call it y squared equals the square root of 53 squared. Okay, that means 4 plus y squared equals 53. That means y squared equals 49. That means y equals plus or minus 7. It's up to you to decide whether it's plus or minus 7. So which one makes sense? I'm going to put 7 on here and just remind you that we're going up. So I know that has to be a positive 7. Okay, so we've got our triangle drawn, and now we can go ahead and figure out everything else we need in this section right here. And here's the great part about half-angle identities. They all require the same trig function. They all require cosine, cosine, cosine. It's just nothing but cosines. So that makes it a little easier for us. We only have to figure out what the cosine of A is. Or in our case, the cosine of phi. So the cosine of phi equals what? Well, you can either look at your triangle, or you can remember it's the reciprocal of the secant value, which we already figured out. Well, that's kind of sad. That makes it a little easy from what I've given you here. Okay, well, I will probably fix that problem. But let's use this information here. Cosine equals negative 2 over radical 53. And we're going to go ahead and solve this now. I'm going to say sine of phi over 2, which equals plus or minus the square root, this is the big guy, 1 minus cosine phi over 2. And what is cosine phi? Well, it's this thing, okay? Let me get some different ink here because it's starting to get a little cluttery. It's this value here, and we're going to substitute that right into this identity. So here's what we get. Sine of phi over 2 equals plus or minus square root of 1 minus, hold on, negative 2 over square root of 53 all over 2. I know it's ugly looking, but that's your answer. And if you want, we can simplify this a little bit, right? 2 negatives make a positive. Okay, we can get rid of those parentheses, clean this up just a little bit. My 53 is looking scribbly, so I want to redo that. Keep this a professional video here. Okay, 1 plus 2 over the square root of 53, all divided by 2, all inside another square root. If you want, you can simplify this more. You can rationalize and simplify all day long, but I will accept any answer that is basically correct. Okay, even if it's ugly with square roots inside of square roots and fractions and all over the place. The one thing we haven't talked about yet in terms of this problem is, are we plus or minus? Okay, so think carefully on that for a moment. See if you can figure it out. I'm going to answer that question in just a second. Let me clear some space here. So here's the answer. You might be tempted to say, well, my triangle's in quadrant 2. That's true, your triangle for phi is in quadrant 2, but your triangle for phi over 2 is going to be over here somewhere, right? This is phi over 2. And if phi is in quadrant 2, then phi over 2 must be in quadrant 1. How do I know that? Well, think about it. I'm saying this. I'm saying phi is less than 180 degrees, but it's greater than 90 degrees, right? That means phi over 2 is less than 90 degrees and greater than 45 degrees. Okay, kind of where I drew it over here. And you can either convince yourself of this visually using the coordinate plane or just do some algebra over here with the angles. Now, if phi over 2 is in quadrant 1, okay, that's what this means right here. This is in quadrant 1. What is the positive or negative sign that's appropriate on the sine trig function? Well, sine trig functions in quadrant 1 are always positive. And yes, I know in this problem it would have been the same either way. Okay, if you did quadrant 1 or quadrant 2. But be careful because when we're coming up in the cosine one next, now it really does matter. If you said this was a quadrant 2 triangle, you would say that's a negative cosine, you would be wrong. It's a quadrant 1 triangle because we're really talking about phi over 2, not phi. So phi over 2 is in quadrant 1. That means cosine is going to be a positive value. Sine is going to be a positive value. Tangent is going to be a positive value. Okay, you have to really keep track of not only this equation right here, but also what's really going on with that positive or negative sign in front.